So we're at the lathe. So just to explain this, and I've got the paper drawing back out for this just because I don't think it shows up that well on the screen. So this is the piece that we're going to make. So if anybody's following along and making this to these drawings, the dotted lines here, all of the dotted lines or the dashed lines, are basically, you need to be making that up as you go along, almost based on the size of the die or chuck or whatever you're putting in. So the bore through the centre obviously needs to be big enough for the biggest die diameter, so the biggest thread diameter that you're going to produce with the die, so that it's clearance on that thread as the thread moves through the unit. And obviously the counterbore diameter at the front, and the OD again at the front needs to be to suit whatever die or the big, the die size that you're actually making this unit for. So I hope that makes sense. It sounded a bit garbage, so if anybody's got any questions on that, please feel free to contact me and I'll try and do a better job of explaining what I mean. But yeah, the only thing that's fixed really is this length, the 22mm length, and the 40mm diameter at the back to interface with the sliding part and the slot for the retention screw. So they're the kind of fixed dimensions. Everything else is, die dependent or chuck dependent or tap or whatever you're making this to suit. So we'll kind of make that up as we go along on this project. I'm not going to put the dimensions on this drawing because they're specific to the actual die that I make, the die holder unit that I'm making, so that won't suit everybody else. So I'm leaving that all open and undimensioned. So that's that. So what we're going to use is some of this. So this is EM1A, mild steel, bright bar. This was an eBay find. This has come from industry. And basically there was a box of these bar ends open for bids, and I think I got 5 of these for 15 quid or something like that it was, so varying different lengths. I know they've come from industry because if you look at the back here, they've been turned with a chamfer on, and what that is, that's come off an industrial lathe with a bar feeder on it. So this would have been a 3 metre probably length of bar at one point. And the first thing you do on a bar feeder is turn a big chamfer on the back, and then when you then put that into your bar feeder, there's a cup on the back that locates on that chamfer, and that stops the back end of the bar rattling around in the bar feeder as it's gradually feeding the bar through on a CNC machine. So as I say, I've got a few of these, so we're going to make, I think this is 42mm diameter, and the biggest diameter I need is 40, so this will be fine for making the sort of cartridge that I need to make for the M8 die. So that's the die I'm going to make this one for. So I'll bring you back in a moment when we're setting up and making a start. Okay, so we'll get this first piece loaded up in the chuck. Unfortunately it won't go, it's just too big to go through the bore of the chuck, but so it means it's stuck out quite a long way, but I think it'll be okay. We're not going to be going mad with this. One thing I do need to do is give this lathe a really good clean out. I've got a massive pile of swarf now in the back, and at the moment it's not too dangerous because it's not behind the chuck, but at some point that's going to start getting dangerous. If you have some curly swarf that gets hold of that and starts wrapping it around the chuck, that's going to be quite a dangerous thing. So one thing I don't know is, and this is a question to any other YouTube machinists out there that are doing this kind of thing, or even if they're not doing it on YouTube, just home machinists, how do you get rid of this stuff? Yeah, it's something that I've not even considered yet, but I don't know. I'm guessing bagged up and taken down to the local waste disposal site, but I don't know whether they would take that, so that's a question I've got to ask them. But if anybody else has got any clever ideas on how to get rid of this, please let me know in the comments, because that will be useful. Okay, so I'm just going to power the lathe up and we'll get cracking with turning the first cartridge. So we're going to start off by facing this end up and getting rid of the dimple that's in there from the drill. So that's the first operation. So we'll just do that now. Well, what a pleasant experience. I think everything I've machined to date since I started in this workshop has either been stainless, O1 tool steel, or some other nasty unknown material. How nice to machine something that behaves nicely. Okay, so we'll start now. I'm just going to make some marks with a rule on the bar for my sort of depths, and then we'll start turning the OD down to finish size for fitting into the cartridge. Okay, so I've put a mark on my bar, how far back I'm going with a marker pen, largely unimportant, and I'm probably going to go a bit past that so that when I'm parting off I'm not sort of parting on a shoulder, if that makes sense. So I'll probably go a little bit past that mark. So we need to get this down to our 40mm diameter now to fit into the cartridge. So I'm going to take this fairly steady, probably 0.5mm depths of cut, see how it cuts, and then this is 42 at the minute, so that gives me 4 0.5mm cuts effectively. So I'm going to go for the balance cut approach again to hit my finished size. So I've got 4 rundowns. I'll use the first one to check that I'm getting a decent surface finish and you know, swarfs as well under control as it can be, and then we'll start measuring and sort of working my way in the 0.5mm depths of cut. Took 2 0.5mm depths of cut there because the bar's running out slightly. It was 0.5mm wasn't enough to clean it up, or neither was a mil, so it's still not cleaned up there. It doesn't matter, it will have done by the time I get down, and I've gone past the halfway point so I can get a measurement off there now. So we'll see what we've got. Let's use the vernier for this first measurement. So we're on 41.5. So we'll take another 0.5mm, that should get us to 41. Okay, we'll just measure that again. So 4105. I've just speeded up the feed because I'm not getting the best surface finish on there. Visually it's not good. It feels pretty good. So I've just speeded up the feed rate a little bit and just see if we can get a slightly better finish. I'm never going to get a brilliant finish because I'm only taking 1/2 mil depths of cut, so it's only, well, I'm taking 1/4 mil depths of cut because I'm taking 1/2 mil off the diameter each time. It's not enough really for carbide to give you a good finish, but because I've only got 2 mil to come off, I'm fairly limited. So we'll give that another 1/2 mil and see what that looks like, see if it improves the surface finish. I think that might be a bit too aggressive. We'll slow that back down a bit. So we'll start measuring now with my new metric measurement gear that, if you watched the last workshop blether, you'll have seen was a viewer mail gift, which is going to make my life a lot easier. So we're there 40.63. So we're 0.63 to come off. I'm just going to slow this feed rate back down. Check that again, that should be us on our finished size, hopefully. So I'm aiming for 39.95 to 39.98 is my finished size, so that I'm leaving some clearance on the, slight bit of clearance for the fit. Whether it's just going to focus. So I'm 39.99. So I'm one micron up. But what we can do is just check that now. I'm sort of in a mix really, because when I machined this piece, the bore, the fine limit bore, I was using my snap gauges and I was converting to imperial and using an imperial micrometer, so there will be measurement error between those two micrometers. So we're just going to check the fit on this piece and see whether it goes in. Yeah, perfect. That's just the fit I wanted. Yep, that's good. So again, not the best demonstration of balance cuts there because I was messing around with feed rates between each one. Not ideal, but again, it shows that having the confidence in your cutting and just taking it and going straight for it rather than creeping up with tiny little cuts and probably risking going undersized and then having to spend, or being slightly oversized and spending ages with some of this stuff trying to polish it. And it's far easier to do what I've just shown there with balance cuts. So the next thing we're going to do, we'll just get our die. So I'm just working out now whether I need to turn the front end diameter down slightly for this particular die. And looking at that, what I'm looking at there is how much thread engagement I'm going to have of the grub screws that are going to hold this die in place. and I'm going to be probably using M6 grub screws, and so that's M6 by 1, so each rotation of the screw is going to advance it by a millimetre. So I'm looking there, there's about 5 millimetres, probably potentially 6 millimetres, so I'm going to have 6 threads in engagement as I bite down onto that die. I think I'm going to leave that. I was questioning there whether I turn the front section down slightly so that I've got, you know, slightly less, but I think 6 threads will be okay. So we'll leave that as it is. That's good. So we'll just chamfer that now on that front. So I'll get some tools together now, and we're now going to poke the hole through the middle and bore it out at the front to suit the die. And I'll bring you back when I've got the tools collected for that. So going back to what I was saying about the dotted lines on the drawing, I've just dragged some of my dies out just to see what my range is. So if I look at all of these, I've got M3, M3.5, M4, M5, M6, M8, M10 and M12, and they all are there or thereabouts the same outside diameter. So this first cartridge I'm making will manage all of those thread sizes, which is really good. So M12 being the biggest there, my next die up is an M14, and you can see there that's a much bigger diameter, so I'll need to make a new cartridge for 14, 16 and beyond. So based on the dotted lines that don't have dimensions on, M12 is the biggest, so the hole I need to poke through the middle needs to be clearance on an M12 thread. So I need something that's, you know, I'll probably go for a 13mm drill through the middle to put that clearance hole through. And then we'll obviously bore it out at the front end, counter bore it out to suit the OD of this whole suite of dies. So what I'm probably going to do is, and I'll do it off camera, I'll measure all of these dies up more accurately, and I need to find the biggest, and we'll make the counter bore to suit the biggest. They're all within you know, probably 1 of each other on outside diameter, so I'll find the biggest one and we'll make the counter bore to suit the biggest die out of that set. So I'll bring it back at the lathe, we'll get some tooling together and we'll start machining those features in. Right guys, what we're going to do here is centre drill, then we're going to put a 6mm drill down, and then we're going to follow that down with a 13mm drill, and that will give us clearance on our M12 thread, which is our biggest die. So we'll crack on with that now. So at 800 revs a minute, that'll be good enough for the centre drill and the 6mm drill. Right, so what I'm going to do now is bore down with a 20mm drill to my just shy of my finished depth of the counterbore, just to give my boring bar some clearance in the hole. So we're going to put this down about 9mm. So what I've done there is set the drill so it's just about touching the existing 13mm hole. I've zeroed out the scale on my tailstock, and I'm just going to wind in 9mm, and then hopefully I should be able to get my boring bar in then and flatten the bottom face out. See if we can bore this out for the die to fit in the front. So let's have a go at this. And just give that a rough measure and see where we're at. So we're 20.6 diameter. About 8mm deep. So I'm heading for about 25, so we'll take a couple more cuts out of there. So 24. We want 25.2, so we've got 1.2mm left to come out. that's a perfect fit. So I just need to get my depth right now, and the die is 9.3 thick. So if I go for 9.5, something like that, I think. So we're currently at 8.2, so a bit of material to take out the back. There we go, that's the counterbore finish for the die. So all I need to do now is just chamfer this front edge, and I'm just going to use the Noga for that, or the Noga copy. Okay guys, I've got the parting tool set, so we've set this square to the job, and I've just measured in with a rule to the depth, so we're going to part this off at 32 millimeters. Oh, it's nice working with decent material after being stainless and 01 and everything else. So, so there we go, that's got that bit parted off. So I'm just going to flip that round now, and we'll just face this back face, get rid of this, and we'll just break the edge in the with the countersink and put a chamfer on it. Okay, we'll swap that back round in the chuck now, so we've just got that held quite lightly. I've not nipped it too hard so I don't mark, hopefully, too much, or if at all, the OD. There we go. I've put a good size chamfer, on that back corner, and the reason being is in this piece that it's going to fit into, the mating piece, there's obviously a radius in the corner there from the CCMT insert, so I just want to make sure that that chamfer's big enough so that it doesn't foul on that corner radius. None of that's measured. I'm just doing all of that by eye, really, for what this is. It don't need to go too daft. So that's that bit made, certainly in terms of the turning element. So I'll just bring you back at the, we'll go back to the surface table now, and we'll just loosely assemble all these bits together and just have a look what it looks like. And then there's just a bit of milling and drilling work to do to finish the whole thing off. Not the best grinding job in the world, that. I just done it quick just to see whether it's going to work. It's got the material out. That's the main thing. Just check my diameter, and I've just ballsed it right up. So what we'll do now is face all of that off and start again. And what we've done there is ballsed it right up again. I'm having some fun with this. So, oh, there's going to be some good outtakes on this video. So I'm not looking at the drill going down the hole, I'm looking at the, while I'm doing that, I'm looking at the scale on the back of the tailstock here. So, thinking this is metric. And busy ploughing away. It's actually imperial, so what I've actually done there is gone down 900 thou rather than 9mm. So we'll recover the situation a second time, and then I'll bring you back when we start doing some sensible machining.